Seriously. Oh, come on. So open your R and the R Studio. And let me show you the data set. So we have some couple of variables. These are variables. They represent certain things. There are 6 variables. They have some numbers associated with them. Now, we don't have dependent variable. We don't have independent variable. The only thing we have here is variable. 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 Now, these variables are so many. We want to coalesce them. We want to combine them into a certain number of components. Okay? And that is the essence of our presence today. 6 variables. Let me give you the details of the variable. The first variable here is called waiting time. Waiting time. Just take note. Waiting time. The second variable is taste. Taste. I'm going to ask you a question also. Pay attention. So the first variable is waiting time. Waiting time. The second is taste. The third one is cleanliness. 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 The fourth one is temperature. 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 And the fifth one is freshness. 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 There's another variable I've forgotten. Oh, and then there's another variable which is friendly employees. Friendly employees. Friendly employees. So take note of this. Who can tell me the first one? Either type it or mute yourself and tell me. First one?
Taste.
No, the first one is not.
Waiting time.
Waiting time. Second one?
Taste.
Third one?
Cleanliness.
Fourth one?
Temperature.
Fifth one?
Freshness.
Freshness.
Finally,
Friendly employees.
friendly employees. Now pay attention. I want each one of you to group them together. By the way, this is talking about which industry? Which industry do you think this is talking about? Or which company like is this talking about? Which organization?
Restaurant.
Raise your hand and tell me. Raise your hand and tell me. Or type it there. Which organization is this about? Which organization? Only look at it. Margaret.
Food and beverage.
Food and beverage. Very good. Food and beverage. What else comes into your mind? Seth Kunsen. What else?
Hospitality industry.
Hospitality. That's the industry. Now let's go specific. Let's zoom in. What are we talking about here? What are we talking about here? Josephine.
No, please, a restaurant.
A restaurant. A restaurant. Or what? Or what? A restaurant. Or what? So food and beverage, that's also an industry. Okay? So we come to restaurant or canteen or hotel.
Choba.
Choba. Thank you. Choba. That's a canteen. You be eating certain things. Eh? Very good. So I want you to now group this into 2. Just group them into 2. And I'm going to ask you, where did you put one group? There are 6. So group them into 2. The grouping could be 1 against 5, 2 against 4, or 3 against 3. Group them into 2, and let me see. Be careful. How will you do the grouping? You must think of certain things that they share in common. Certain things that go into one angle, and certain things that go into another. When you are done, raise your hand and tell me. You see, what you are doing is that you are thinking about something. And that is the same thing what we are going to do in the software is going to think about. Have you gotten the grouping? Who has gotten the group? Who has grouped them? Let's see. Who is ready? Who has done the grouping? There's one particular one that is troubling you, right? There's one particular one that is troubling you. You've done the grouping all right, but one is really, really hitting. Who has done the grouping? Have you done the grouping? God. Mavis. I need your grouping number. I need your grouping number. Let me go to Alex Pobidam. Are you there? Alex.
Yes, Doc, I'm there.
Have you finished your grouping?
Yes, Doc.
Tell me your grouping.
So the two groups, there's one that has two of them. So number 1 and 6, I grouped them into relation to humans.
Use the names. Use the name. Don't say 1 and 6.
So the waiting time and then friendly employees. They are in one group. Then
Okay.
taste, cleanliness, temperature, and then. Sorry?
Why did you put them in one group?
So I see that for the waiting time, it has to be determined by a human being. Then friendly employees also has to do with you are relating with your customers. So you need employees who are very friendly and they can receive the customers that comes to the restaurant.
Okay. So the other 4 too, why did you select them? You don't need to tell me the other 4. I know them now. What led to the grouping them together?
So I looked at, for example, in a restaurant, we have to be dealing with food. So food has to do with temperature and how fresh the food looks like and how clean the food looks like and how it can be served diligently.
See, very good, very good. We'll come to another person who had a different grouping. Who had a different grouping. Whether he's right or he's wrong, I won't say it yet. Else it will influence your thought process. Who has a different grouping? Yes, Seth Kimson.
So, Doc, I had a different grouping. I had 3-3. So I had waiting time, taste, and temperature, one grouping. And I also had cleanliness, freshness, friendly employees, and temperature.
Okay, so let's go to your first one. You had waiting time, taste, and temperature, right?
Yes, please.
Why did you group them?
So I actually used the fact that let's say, a hospitality industry or let's say a food and beverage business, the waiting time, the taste, and temperature are factors that the business itself has control over. And then the other aspect, when it comes to the cleanliness, the freshness, the friendly employees, those ones are factors that the employees themselves can have control over. So I categorize them based on what the employees can have control, and then the factors that the business itself has absolute control.
Guys, you've done well. I'm sure the others will share the similar work with you. Both of you did well, but both of you were slightly beyond the mark. So I'm going to show you the groupings. This is the groupings. Check the groupings. Match that to your grouping. One was about the service quality. Another was about the food quality. Yes, one of you said that the waiting time and then the friendliness, they all deal with human beings, which was good. So that is quality of the service. But what the person missed is that cleanliness also had to do with the service quality. It has to do with the person, the cleaning of the place, wiping out the dirty things. That is an example. So you see, what we have just done is that instead of having 6 variables, we now have two variables. And these two variables are the factors or principal components issuing out of these variables that you have. And so there's something that makes these three combine to make the service quality. And there's something that makes this, the other three, taste, temperature, and freshness, combine to form the food quality. What we are going to do is to go into the analysis to find some things that are very, very interesting. So the first thing I want you guys to do is I want each one of you to go to your Excel. Come on. Go to the Excel. Computer is frozen a little bit, but let's just wait a second. Go to your Excel and generate a correlation matrix. That's all I want to. Once you've generated your correlation matrix, type 1 in the chat or raise your hand. So go to the Excel, generate a correlation matrix of the data set. So I'm going to the data set and show you the data set. I just want you to generate a correlation matrix in Excel. Nowhere else. Just do the simplest one in Excel. In Excel. Who is done? Who is done? It has to be fast. I know you've learned it already, under regression. So you should be able to generate a correlation matrix. Life is not all about R, everything R. Okay. So who has generated a correlation matrix? I knew some of you were smarter than this delay time. Generate a correlation matrix for me.
Doc, using the data? Oh, we don't have it.
The Excel data on your screen, which you have. Using the Excel data on your screen, which you have, generate a correlation matrix. And when you are done, just let me know. Guys, I'm going to give some people some crazy maths. So it's very important that you focus on what we are going to do today. Class rep, are you there? Is my class rep around?
Yes, please, I'm here.
Okay, I'm going to give some 3 marks to some 3 people. So get ready to know the
All
other.
right. Hey, you.
I know some of you are going to be copying. But I asked you a question that shows that you didn't copy. I need a first person. You've got, is it that you don't know where the correlation matrix is on your laptop? Is that it? Abna, you don't know the correlation matrix on your laptop? Mavis, have you done it? The thing is that you don't have the laptop in the first place to be doing it. That's a challenge. That is a challenge. So normally, it's nice that you have a laptop or you go be with someone doing time like this for this course. He's done. You've got 1 minute. By the way, did Dr. Hanan take you through Excel on how to get correlation and regression? Did you do it in Excel? Class rep, did you do it in Excel? Class rep.
Hello, Doc.
Yeah, answer me.
No, please.
Is that why you're struggling?
I think so.
You'd have told me that you haven't done it. How can you go and do things in R when you don't even know the basic things in Excel? Yes, Margaret. Yes, Margaret. What's your question? All right. So the first thing you want to do is go to the data tab. Whilst your screen is there, just go to the data tab here. On the far right, you should see data analysis. On the far right, you should see data analysis. If you don't see data analysis, raise your hand. Now, click on data analysis. Data analysis dialog box will open. The data analysis, dialog box is going to open. Now, look for correlation and click on correlation. Yes, Josephine, what's your question?
And please, I don't see data analysis.
Okay, so it means that you've not been using your Excel a lot. On the far left, you should click on File. Done that? On the far left, click on File. Have you?
Yes, please.
Options. You're the only one I'm talking to, so you got to really respond. Options. At the bottom, click on Options. Look for add-ins. Add-ins. And then on the right, you will see active application add-ins. And when you come down, you will see inactive application add-ins. Under the active or inactive application add-in, you will see analysis toolpack. I'm not talking about analysis toolpack VBA, no. I'm talking about analysis toolpack. Click on analysis toolpack and come down and select Go. Under manager below, select Go. And when you select Go, a pop-up will show. In that pop-up, check the box on the left of analysis toolpack. Check that box and click on it. You should see data analysis now. Let me know when you can see it. Let me know when you can see it. Okay, Margaret, your hand is up. Margaret, any reason your hand is up?
Doc, please, I wanted to say that the observation, the variable 1 and variable 3 have a strong positive correlation.
But I've not asked you that.
Oh,
I've not asked you that. We are trying to generate a correlation matrix. All right. So click on data analysis, select correlation, and then under correlation, you see a box to appear.
No,
that
we are
box,
using Excel. Hello, Doc.
yeah,
Hello, Doc.
yeah.
Yes, please, after following the instructions, I still can't see.
Yeah, you didn't actually follow the instructions. Because I told you to let me know each step of the way what you do. You tell
Please,
me.
my hands was still up, but you
No, I
didn't
didn't
call
have
me.
to call you because I already told you that you were the only person I was talking to. All you
Oh,
had to
okay.
do was to tell me, yes, I've done this. Yes, I've done this. No, I've done this. But there was no response.
No, please, I'm sorry.
So start again and tell me what you click. Tell me step by step what you're clicking.
Okay. No.
Speak out.
So you said I should go to file, options, and then add in, and then I should click on analysis toolpack, and then click OK.
No, you don't click
No,
OK.
okay. You said go. Okay. And then on the far left, I'll see in the box, I'll see some add-ins available.
That box.
And
You will
please, you
check.
say,
You will take the
okay.
box. There's an
And
analysis.
then
Don't
yes,
click
and then
on it.
I take.
You have to take that little box on the left of analysis toolbar. Don't just highlight the words, but take the box.
Okay. Yes, please, I've taken.
And then click OK. And when you click OK, come back and now go to the data tab.
Okay. Data. Yes, please, I've seen it now.
Yeah.
Thank you.
Actually, it's possible that it was there. You didn't click on data tab again, did you?
No, please, I didn't.
Yeah, it was there. All right. So now click on the data analysis and choose correlation in the list. Everybody, once this pop-up comes, okay, that is a correlation parameter dialog box. When this correlation parameter dialog box should pop, when the correlation parameter dialog box should click, what you should now do is on the top of your data, go and highlight all the variables. Okay, click inside the input range and then select all the variables like this. When you exceed it, come back. When you exceed it, come back.
Hello, Doc.
Yeah.
Please, we don't have the data.
You don't have the Excel data?
Yes, please.
It's in the group page. No. I sent you last week as well. Who had that?
Please.
Who has the data? All right, say something on the page. So when I was describing the data all along and you guys didn't have it, you should have told me that you didn't have it. But you see, Finder has posted the data, which means you have it, isn't it? Finder. Finder.
Yes, Doc. Yes, you posted it last week Sunday.
And they didn't see it. You were the only one who saw it. It just shows how serious some of you are and how not serious some of you are. It just shows it. I mean, the serious ones will always remember that I posted it. Okay. So looking at this data, what you have to do now is to copy this data into this section here. Then after that, take the labels in first row and take the new worksheet. That's it. Take the labels in first row and take the new worksheet. That's it. After taking the new worksheet, type the name of the data of this worksheet. So I'm just going to say call for correlation. And once you are done with this, click OK or enter. I am just doing enter. So it says correlation. Okay. So let me be sure that, okay, so my data set has changed. So come and then redo for the data highlight. Highlight all of the data, ensure the columns is ticked, take the first row, and then create a new worksheet. And then call the worksheet call and click OK. So that's it. A new worksheet has been created, and now we have the data set created on one of the sheets. Who has been able to generate this? When you are able to generate the correlation matrix, raise your hand and let me see. I'm checking those who have done it. I'm going to verify, so don't just raise your hand. So I'm going to give marks to the first 4 people who raise their hands. Class rep, please take note of the first 4 people whose names are put in the page, in the group.
All right.
Verify what they did. So those first 4 people, the first one is Christopher. Christopher, did you do it on your laptop?
Yes, Doc. Please, the name is Christophane. I did it on my laptop.
All right, Christopher. Very good. And you generated a correlation matrix very nicely.
Yes, please.
Guys, when you have the correlation matrix like this, everything you see is in decimals. Okay, it's in multiple decimals. So you can say you want it in only 1 or 2 decimals. 2 decimals is key. So at the top of the home tab, click on the home tab. Click under the home tab. You will look for general at the top. General at the top. Select general and choose number. Everything will be in 2 decimal place. Select general, choose. So what I want you to do now, when you choose the number, everything will convert to 2 decimal places. Okay. Everything will convert to 2 decimal places. If yours has converted to 2 decimal places, please type the letter Y. If yours has converted to 2 decimal places, type Y. Let me see. Okay. I'm not giving marks for that. I'm just trying to make sure that people are not following because of just marks. Class rep, please. The names I took in information from you, you're going to give them 3 marks each. And you'll be sending me this every week. Okay?
All right.
Class rep, are you part of it? Okay, so ladies and gentlemen, we're going to address
No,
some.
Doc. But
Okay.
I raised my hands, but then my name wasn't there. So.
All right. So we're going to do everything we've done here in R. So open your R Studio. Open your R Studio. I have my R Studio beautifully open there. So you too open your R Studio and lower your hands. Open your R Studio. And I think you have never written your code. So we are going to do it for the first time. Okay. So I want you to go into your RStudio. When you open the RStudio, you have an empty blinking point here. So please follow me and type what I would suggest to you. So you're going to type a command. Just type what I'm typing. EG equal to read.delin. Then inside the bracket, type double apostrophe and type clipboard. Type double apostrophe and type clipboard. You can always add an instruction with a hash symbol. After the hash symbol, add an instruction. Say, this copies your data set from Excel to R. Let me know when you have typed the first command. Let me know with a yes or hand raise when you have typed this first command. Okay, go to your R Excel, the restaurant Excel. Go there in your Excel, copy the entire data set, you can click anywhere in the middle of the data set, then you do Control A. That will select everything. Then you do Control C. That will copy everything. Then come back to this RStudio where you have already typed the example command. Click anywhere in that example command, and then at the top, run it. You can click run or do Control Enter too. Once you do that, you have the data set showing down there below in the console. Okay, now you've been able to do that. Everything is numerical, so we are not bothered about categorical example. But there are some few things you can do with this data set. Okay. We are going to generate a correlation matrix. So type plot into bracket. Yes, Christophine. Your hand is up.
Oh, sorry, Doc, it was from.
Okay. So you have your command, then type plot, then type the name of the data set. We called it EG. And type command, comma, and then type COR for correlation. COR for correlation. And then when you type COR for correlation, the interesting thing is that you have to specify clearly now let's change something. Okay. After your EG, do comma and type COL for color. COL for color equal to, type COL for color equal to, and you can choose any color. Okay, bring double apostrophe. Inside the type blue, you can type green. Okay. Inside a type blue, you can type green, and then do a comma and type line weight. LWD, line weight, and type 3. Some of you can type 2, some of you can type 4. The line weight will tell you the way you want the correlation to do. Run it. And on the right here, you should see something like a correlation matrix. This is actually called a scatter plot matrix. So you see a scatter plot matrix on the right, like this. Generate that scatter plot matrix. And after you've generated it, type number 1 in the chat. After you've generated it, you type number 1. After you've generated, type number 1. I still need more people to truthfully type number 1. Okay. So I've gotten some 10 people or so who have actually typed number 1. In class rep, I'm actually documenting their names. Each one is going to be getting 2 marks for class participation. Okay. I've posted their names there. You see it. Anybody else cannot be recorded. Now, this is not to say that you can easily lie to me, because I can always let you prove this to me. And I will always do that. So you've been able to generate a correlation matrix, but that is not enough. It's just a graph. The correlation matrix will tell you whether there's a positive or negative relationship. Okay, that's all. Now we can proceed and actually do a correlation itself. So type around to brackets or into bracket the name of the data set. Step out of the bracket, and then you do 3. 3 means that you are rounding the correlation correct to 3 decimal places. So that's what you can see there. Generate a correlation matrix table. The first one you generated was actually a scatter plot matrix. Now we are generating a correlation matrix table. This is what I have generated down there right now. Type 2, if you have been able to do it. If you've been able to generate the correlation matrix, type 2. Can't transfer. Wow, I'll fail you. I'll just simply fail you in the entire exam. That's all. Because you've insulted my intelligence, if you lie to me. Charity Afrifa.
Dog.
Show me a picture of yours.
Please. I have joined with my phone and I'm doing the thing on my laptop, so I will send an email.
To show the screen for the laptop. Let me see. Point it. Point the screen to it. I want to just verify. Just look on the phone and click the back that shows the laptop screen. Look at the phone and you see the arrow that goes back. Do that for me.
Which arrow?
Oh, what is which arrow? That's it. What you did before. Do it again. You're not supposed to see yourself. Calm down small. Calm down. Okay, perfect. Hey, but wait. Okay. Hold on. Stay there. Why are you putting the names T1, F1, blah, blah, blah? Why?
Sir, the waiting time, the taste, and the cleanliness.
You change them?
Yes, please.
Okay, let me look at it again. If you change them, let me see. So the last one, which is F and then FE, what do they stand for?
The F is the freshness and the FE is the friendly employees.
I love this. I love this. You've done well. I mean, you didn't stick to this. You gave it your own name. That's really good. Excellent. Very good. Oh. All right. So that is excellently done. That's really.
Okay. Thank you.
Yeah, welcome. You've done well. And I think your colleagues have all done that. I just picked you up to be sure that you're on the right track. I can't find my screen. Oh. Do you guys see my screen?
Yes, Doc.
Yes, please.
How come I can't see my own screen now? I'm going to press somewhere. The place I wasn't supposed to press. I'm going to press there. And now, oh, okay. I can't find my screen. All right, so classroom, give a mark to Charity for me. Okay. 3 marks to Charity for me. Oh no, I can't find my screen, man. Which one do you normally use to find these screens? No. Okay. I think I can find it now. All right, so now let's ask some few questions. These are principal component analysis questions related to what we are doing. Question number one.
Hello, Doc.
Yeah.
Please, I got error for that one, and
Check the spelling. Read what you typed and let me see.
so round bracket open COR, another bracket EJ, comma 3, then bracket close.
Now, comma, the bracket must close before 3.
Oh, okay.
There's always mistake like that.
Okay.
Let me know when it works.
Still not working.
Okay. So after the EJ, you close the bracket, then you brought a comma and then you wrote 3.
3, yes.
So comma 3 before you close the bracket.
Bracket again, yes.
Now, when you first loaded the data, did it show at the bottom in blue?
The first one.
Yeah, the first command, which was EG equal to read.delem, and you ran that. Did it show
Yes, I
blue?
did. Not at the bottom, but on the side.
No, it's supposed to show blue in the console at the bottom of your screen.
Okay.
Are you using your laptop?
Yes, please, I'm using my laptop.
Are you talking with your laptop?
Yes, please.
You have to share your screen.
Okay.
You have to share your screen. That's the only way I can be of help.
Okay, please. I'm sharing I'm trying to. Okay.
All right. So go up small at the bottom. Go up small at the bottom of your screen, the console. Scroll up small.
Okay.
Keep scrolling up. Okay, it's okay. Calm down. Okay. All right. So your data showed, but it showed in the view section.
Yes, please.
At the bottom. Okay, so just highlight only the EG. Highlight only the EG right now and do Control Enter. Only the EG. I didn't say the rest.
Oh,
only the
sorry.
EG. And do Control Enter. Okay, so this is a data set. There's a problem in your data set. The problem is that your data is not showing the data.
She copied the regression instead.
Go to your Excel. Go to your Excel and let's see the data. Is that what you copied?
Yes, please.
You should have copied the actual data. Go to restaurant. That's why.
Okay.
No, we shouldn't have copied that.
There's always a mistake. Click on restaurant at the bottom of the sheet.
Sorry, please let me open it again.
Yeah, just highlight this. Control C, anyway. Control C to copy, then come to the R and run the first command. If you want to copy it, it's on your clipboard. It's on your clipboard, just like you don't see it. Click on the first command, yeah, and run it. Control Enter to run. And now run the next one.
Okay.
And then run the next one. So you should have it now.
Yes, please. Thank you.
All right. On share your, okay, I'll just take over the screen share. So guys, one thing you can see right now is that you will notice that we have this sort of regression, correlation and all of that. So I have a question. The first question you will always get in a principal component analysis is this question. Question number 1. Take note. Using the rule of thumb in PCA, which variables appear to be strongly correlated with variable 1? Which variable is strongly correlated with variable 2? Now, what is the rule of thumb in PCA for this module? The rule of thumb is very simple. That because you watch the word, which variable is strongly correlated with variable 1? So you check variable 1. Okay. You see this? I'm using the R version, variable 1. Which variable is strongly correlated with variable 1? You check this column here. And you will pick the variable, irrespective of the sign, whether it's negative or positive, pick the variable that is strongly correlated with variable 1. So in this case, which variable is that?
Variable 3.
Variable
3
3.
3. 3 is the first one. But then the rule, it says that the variable must be, and listen carefully, it must be 0.8 and above. It must be 0.8 above. So let me show you something. Oops. Sorry, not 0.8 above. It must be 0.3 and above. So the rule of thumb is that any variable that is 0.3 and above is highly or strongly correlated with the variable in question. So you're rather looking for a variable that has got a correlation coefficient of 0.3 and above. And always try, and this is important, always try and round it. Round it well. Which variable is that? Oh, what was the question? It says which variable is strongly correlated with what? Variable 1. Okay, variable 1. Which variable? Who raised their hand? Somebody raised their hand. The person got scared. Mercy.
Variable 3.
Variable 3 is one of them. Which other variable?
Variable 4.
Which other variable? Variable 6 is a candidate.
Good. Variable 6 is a candidate than variable what?
And variable 5.
Exactly. Why are we going to go for only these 3? You can guess. And this is it. Because the question was also with variable 2, isn't it? So once a particular variable is correlated with variable 1, it should not correlate with variable 2, relatively speaking. So what you are doing here is that you're looking for which variables are correlated with variable 1 and which variables are correlated with variable 2. But you got to make sure that when the variable is strongly correlated with variable 1, it is not as strongly correlated with variable 2. I don't know if you guys understand what I mean. Does it make sense?
Please come again.
Yes, please.
Okay. So, if you are looking for which variables are correlated with variable 2 right now, if you check the correlation of 5 is also 0.3, right?
Yeah.
5 is 0.3 and above, but 5 is correlated. All of them are correlated with anyone. But when you look at variable 2, it has 43%, variable 1 has 25% in negative terms, of course. Which one will be more correlated with variable 2? 5. 5, will it be more correlated with variable 1 or more correlated with variable 2? 5.
Variable 2.
Variable 2.
Variable 2.
What about 6?
Variable 2.
Variable 2.
Variable 2. What about 3 and 4?
Variable 1.
Variable 1. That is how you analyze it. Okay. So we can say that the variables that are correlated with variable 1 are 3 and 4, and the variables that are correlated with variable 2 are 5 and 6. If you don't understand, you raise your hand. And this is the way you attack this very example. So this is how you analyze it. 3 and 4 are correlated with variable 1. 5 and 6 are correlated with variable 2. So in your own, you're not going to get just small variables like that. You check a couple of past questions, I will give you like 14 different variables. The whole thing will look like Hebrew to you. The whole thing will start looking like Hebrew because you have to come through and come through and come through and come through. But you can understand it now. When there is understanding, there is clarity. When there is clarity, there is focus. Next question. From the matrix, is there a basis for principal component analysis? And this is a justification. For there to be a justification for PCA, 1, this is a rule, okay? Oh. You must have the correlation coefficient to be 3.3 and above. That's 1. The correlation coefficient must be 0.3 and above. But how many of them? 7 of them. 7 of them, 7 of the correlation coefficient must be above 0.3. That's the first one. All you need is just 1 or 2 of them to have a correlation coefficient above 0.8. That is the rule. So when you go back here, check it. Okay. How many correlation coefficients? Remember, you don't look at the mirror image. You're just looking at those in the middle. How many correlation coefficients are above 0.3? So when you're using this one, it can be confusing, but always cancel, take a line and cancel the top right diagonal. So ignore everything on the upper part and focus on those on the lower part. How many correlation coefficients are above 0.3? Correct, round it to 2 decimal places. Who has counted them?
Please, 7.
Sorry?
7.
Are you sure? Do you all get that, or it's a different answer? Because that's not what I think.
7.
1, 2.
It's
7.
7.
It's 7, right?
Yes, 7.
Yes.
You all agree with that?
Yes, please.
Yeah, 7.
Somebody says yes and no. What is
Look,
yes?
I had 9.
Good. I like different answers. Look at this. Look at this.
Okay.
Okay, I had 11.
Look at this. The number is going up, but it's not reached yet.
But Doc, you mentioned 2 decimal places.
Yeah, round it to 2 decimal places. Master, count the thing. This one is above 0.3. This one is above 0.3. Sorry, this one is 0.3 or more. This one is 0.3 or more.
4 by 6, 7.
If you are rounding up to 2 decimal places, then we only get 0.3.
Then what?
We wouldn't get 0.3.
You wouldn't get 0.3. You're rounding it to 2 decimal places. Sorry,
So
did I
you
say
want
your?
decimal place.
Oh
It should be
yeah. Did I say? Did I say 2 decimal place? 1 decimal place. 1 decimal place. No. Let's skip it. Let's skip it. 2 decimal place. I've forgotten which decimal place I used, but let's see. But you're supposed to have, well, you're supposed to have 14. I think 1 decimal place. Let me see. It depends. I've just forgotten. Okay, so it's not point, it's still 1 decimal place, but it's not 0.3, but it's above 0.3. So let's count those above 0.3, but use 1 decimal place. How many above 0.3? 1 decimal place. I think your answer will still hold, right? I counting.
Yeah, it will still be the 7.
It's 7.
It'll still be 7, isn't it?
Yeah, 7.
Yeah, 7.
So you get 7. Okay. So now you will say that 7 correlations are above 0.3, or at least one of them is above 0.8. Now the rule I told you is that all you need is at least one of them is above 0.8. All you need is one. And here, more than even one are above 0.8. Okay. For example, this one is above 0.8. This one is above 0.8. So in fact, this one is also above 0.8. So more than one are above 0.8. So in short, there is a basis of principal component analysis. This is what we call non-orthogonality. So the variables are exhibiting non-orthogonality, and as a result of that, we can proceed to do the PCA. Okay. Remember, it's not all the time you're going to see these answers, because the data here is different from the data you might get in exams. But the principle is the same. Yes, Alex.
So, Doc, in a case where you don't have up to 7 greater than 0.3, and there's one that is greater than the 0.8, do we go by the 0.8?
Yeah.
Or it doesn't really happen that way?
Yes. All you need is one being bigger than 0.8, even if the others are below.
All right. Thank you so much.
Next question. But you see, checking the correlation coefficient is one thing. Checking whether the correlation exhibits significant values are important. So we are going to calculate the significant value. It's not, don't just check whether they are 0.3, more than 0.3, but check whether they are significant. So let's go to the R Studio. And then we are going to run p-value for this correlation. So we are going to generate correlation in addition to the p-value. In that case, you have to install a package which is called H miscellaneous. H miscellaneous. Now you can run a command to install or come to packages on the right here, bottom right. Click on packages. Click on packages and click install. And type HM. You must be on the internet. And I'm sure right now you're all on the internet. And you see H miscellaneous or HM. It's MIS. Okay. HMIS. What is that? HMIS. So this one. And then you click install. You click install. I have already installed it, so I'm not doing this. So you should do that. And once you click install, you see a red dot here, which means it's installing. After that, type require. Then you do into brackets HMIS. You can put a little instruction for your note and say that this is used to do correlation with p-values. So a correlation with p-values. So we're going to use this one to do correlation with p-values. So this require is done anytime you're going to do correlation. So run this command. Type it and run it. And at the bottom, you will see that it says loading require packages. And that's it. It loads it. Then you go to the next command. Follow me. and type R core. R core. Then you bring brackets as matrix. Inside the bracket, you have as matrix. And then inside the as matrix, you type the name of the data. We called it example, e.g. You bring a comma, you type the method of correlation. We are using Pearson's product moment correlation coefficient. So the method is equal to Pearson. Put a Pearson in double apostrophe. That's it. You're done. So this will produce not only the correlation, but a correlation with p-values, with the significant values. Please note that if there are any categorical variables in your data, this will not work. You got to remove the categorical data. Of course, if I am the one giving it to you in your exams, I would have removed it already. If you are doing it in real life, you would have to do the removal yourself. How to do that is simply adding another command called minus which. And then you list which categorical variables, minus which. So you ideally you would have typed something like minus which. And then after this minus which, you now specify you type it in the bracket, not outside. Okay, so do this and run it. And at the bottom, you will see this beautiful correlation matrix. It will have both the correlation at the top and then the p-values at the bottom. It will have the correlation at the top as well as the p-values below. Now, I think you've already done it in regression. That when the correlation, when the p-value is less than 5%, what does that mean? When the p-value is less than
there is a significant difference.
Then it is statistical significant.
Good. It simply means that the correlation is statistically significant. Okay. So the correlation is significant. So let's check the variable, the correlation that you found. Remember the correlation you counted and found. Okay, let's check which one of them. We found 0.95. That is between variable 3 and variable 1. So you come here, match variable 1 with variable 3, and this is a p-value. So looking at this p-value, would you say that first 0.97, is it significant or is not significant?
Significant.
Very good.
Significant.
The next one here, is it significant or insignificant?
Significant.
Significant. Very good. Then you have another one you selected. Was it this you selected? Yes, you selected it because it was bigger than 0.3. Now, when you check it below, is it significant or insignificant? I'm not highlighting it.
Insignificant.
Is it significant or insignificant?
Insignificant.
Insignificant. Okay. You see, the two words rhyme the same way. So somebody says significant. So you have to say insignificant.
Insignificant.
Exactly. But when you say you see that one, you confuse us exactly. So that is insignificant. What about the next one here? 0.69. Is it significant or insignificant?
Significant.
Significant. It's significant. Very good. Very good. Now, how about the 0.85? Is it significant or insignificant? I'll ask you all these. 0.85. Is it significant or insignificant?
Significant.
Insignificant.
Negative 0.50. Is it significant or insignificant?
It's significant.
Insignificant.
You see, somebody said it's significant. That is why I said that, So that's it. If you look at it, it's 14%, which is more than 5%. And then we also had, I think that was all. Oh, this one. Okay, this one here. I think we've done that as well. So, I will ask you not only whether the correlation PCA is sensible to do, but I also ask you whether the correlations are significant. All right. So that is how you determine significant level. Now we are ready to do the PCA itself. We are ready. So there are two functions for PCA. Okay. One of them is print comp and one of them is PR comp. Okay. Print comp and then PR comp. To be honest with you, the best is to use a print comp. So let's type this command, PCA, small letters, equal to, and then you do print comp. Print comp. The moment you start typing, it should come. There you go. Okay. It will pop. It's going to perform principal component analysis for you. The name of our data is EG. So let's type EG in the bracket. Bring a comma and type T. Type T. Sorry. Before you type T, type COR. So we want to just tell it that we want to do correlation. We want it to show me the correlation values. And select COR equal to capital T. That's it. Step out of the bracket and bring a semicolon. And then let's show the results. So type summary into brackets. The name that you gave, we gave the name PCA. So let's copy and paste that same PCA here. And then you also want the loadings. We talk about the loadings. We spoke about it the last time, theoretically. Loadings, sorry, it's in plural. Loadings, and then you do equal to. So this is going to generate the complete principal component analysis results. Not one result, but all the things. Okay. It will print information on standard deviation for each principal component. It will give you information on that. It will give you the percentage or the cumulative percentage of each variance that is explained by each principal component. Okay. So let's run this and see the result. There you go. So keys, see, you got the importance of the components. So we have principal component 1, which is comp.1, principal component 2, which is comp.2, all the way up to principal component 6, which is comp.6. Do you remember we said the last time that the number of principal components will always be equal to the number of variables? And since there are 6 variables, the principal components are 6, but you're not going to take them all. Remember, our goal is to group them into 2 or 3. We don't know which one yet, but we'll know very soon. We'll know very soon. Which variables we should break this into, we'll know very soon. So the first thing we are going to do is this result. So many times in an exam, I'll print this entire result, and then I'll give it to you, and I'll ask you other series of questions. Okay. Now, so the first question I want to ask you is this. What is the proportion of variance accounted for by the first principal component? Okay. Now look at the first principal component. And I am asking the question, what is the proportion of variance accounted for by the first principal component? Remember to correct it to 2 decimal places. Who can give me the answer? Who can give me the answer? Yes, Josephine.
Please, 0.55.
Excellent. 0.55. No question. Please give it 2 marks for me. That's right. Okay. 0.55. Now,
0.55.
yes. Who can tell me the proportion of variance accounted for by the second principal component? Any apai? Apai. Okay.
0.25.
I've not called you. I'm not Makola. Okay. The proportion of variance accounted for by the second principal component. Mary. Evans.
0.25.
0.25.
Oh, why did it take you forever? Okay, so that is 0.25. Now, if a person does not incorporate the decimals, everything will be wrong. So take note. What about the third principal component? You can tell us the answer. The third principal component. Yaira.
0.14.
0.14. Very good. These are all good answers. I'm not giving marks for that, but they are all good answers. Now, let's go to the next question. Who can interpret these answers that you just gave for us? Who can explain let's say the third one? Interpret the third one. What is the third one? This 0.14 that you see here, what does it mean? What does it mean? Evans. Eva. Eva? Oh, she wasn't ready. She just lowered her hand. Yes, Josephine.
So we can say the proportion of variance for principal component 3 is 0.14.
Very good. Now, in your own words, Eva, how will you explain, Josephine, how will you explain this to your 7-year-old sister? What does this really mean?
Meaning the variance or the correlation we can find in principal component 3 is 0.14.
Oh, not exactly. Raise your hand if you have a question. Yes, Glenn.
Using component 3, I would say 14% of the information on all the variances observed in this data set is explained by component 3.
Good. Good. So, guys, watch it carefully. What he said is very, very smart. That's 2 marks. Okay. So, what he said is that 14% of the information, the variability in all the information that you want from this data set has been explained by component 3. Component 3 actually is doing some great things here. It is explaining about 14% of the variance or the variability in the original data set. That is what component 3 is doing. Now, it's doing just 14%, meaning some other components have done a lot. Okay. And the components, if you check the proportion of variances, they are diminishing as you move away from component 1. So component 1 is actually the one that is explaining the most, okay, of the variability or the most of the variation you can detect in this data set. Component 1 is explaining the most, followed then by component 2 and then 3. So what it means is that if I want the information from variable 1 to 6, I can get component 1 to handle 55% of the information. Now, while that is good, it's not good enough. And you'll come to see why that is not good enough. Let's go to the next question. The next question I could ask you is, apart from the interpretation, so look to the
priority. Yeah.
Is this question: what is the cumulative proportion of variance? What is the word cumulative means that you shouldn't always expect the word cumulative. It can be total, can be overall. What is the cumulative proportion of variance accounted for by principal component? Check it. By principal component 4. What is the cumulative proportion of variance accounted for by principal component 4? Michael.
99%.
99%. Excellent. 2 marks for that.
99%.
I said Michael. I don't know who was talking. So that is how you can appreciate this. So take note of the keywords being used here. What is the cumulative proportion of variance accounted for by principal component 1? Barry.
55%.
54%.
55%.
55.
They didn't hear me call Mary. I don't know. It's like people are now fighting for marks, but there was no marks for this. Okay. So I think what I will do is that I will allow you to unmute yourself, and that will help. So I'm going to mute, and then I will allow you to unmute yourself. Okay. Now let's go to the next one. The next series of questions that I will ask you has to do with the eigenvalues and the eigenvector. Now, in case you don't know, okay, and when you check your notes, you'll see every principal component has a standard deviation. Do you realize that? Do you see the standard deviation? Yes, every one of them has got a standard deviation. Now, the standard deviation, write it down, is the square root of the eigenvalues. The standard deviation you are seeing there is the square root of the eigenvalues, which means that the eigenvalues are what? You can tell me. It means that the eigenvalues are what? Raise your hand. The eigenvalues, what are they? Agosia. Is it Margaret and Akosia? Okay, let me go to Joel Asare. Joel. Is it because maybe, but when I ask you to unmute, you can unmute.
Okay, thank you for the opportunity.
Go ahead. Thank you for the opportunity to take on you.
Okay, sorry. 1.348.
What was my question?
Sorry, 1.341.
What was my question? What question are you answering?
Okay.
The eigenvalue. The eigenvalue.
For what? I've not asked you for eigenvalue.
Oh, no, that's what.
No. I asked you, I don't want to repeat it so that the others will be advantaged. But they know exactly what I asked them. So let's go to another person, then you can listen to it. Joel Asare, will you be able to explain to them what it means? The thing is that if I don't block you, some of you are just going to be shouting the answers. That is why I'm trying to allow you to open. Okay, for some reason, Joel, I don't know, but it's like when I allow you, then you can't unmute yourself, so just allow me to do it. Okay. Because you can't unmute yourself, just let me do it for you. Okay, so Joel, now you can unmute yourself. Do it and let's see. Yeah.
Doc, please, it means that to get the eigenvalues, we are supposed to square the standard deviation.
Exactly. That was a question I was asking. I didn't say you should give me an answer. Okay, that is the 2 marks I'm looking for. So the eigenvalues are the variances. After you have squared the standard deviation, you get the variances. So the eigenvalues are the variances. But what you have been given here is rather the standard deviation. So in order to get the variances, you need to square the eigenvalues. You need to square the, what do you call it? Square the standard deviation you have to be able to get the eigenvalue. So that takes me to my question here. And the question is, find the eigenvalues of the first and the second principal component. What is the eigenvalue of the first principal component? Now comes my real question. James.
No, 3.28.
3.28. Very good. That is 1 mark. What is the eigenvalue of the third principal component? The third one. Correct to 2 decimal places. Mary.
1.55.
Again?
1.55.
1.55. Is that correct? James, is that correct?
No, please.
I know. Tell us.
0.86.
0.86. 0.86. Let me see. Yeah, that is correct. James, that is a correct answer. That's also 1 mark for you, James. Okay.
Yes, please.
That is the eigenvalue for this component. Now, you're getting towards the end, so it's very important to note that this next question. And the next question is the loadings. We are going to the latter part, the loadings. The loadings are the weights. The loadings are the weights or the eigenvectors. Not the eigenvalues, but the eigenvectors. So what you see here at this loading, they are the eigenvectors. They are very critical. So every variable, okay, has got that eigenvector. And it is the correlation between the variable and the component. So when you look at it, you have the component at the top and then you have the variable on the far left. Each variable is having its correlation with the component. So here comes my first question. How many principal components that can explain the same information in the original data did this PCA find? I think we've already answered that question, but let me ask. How many principal components did it find? Mary, oh, tripod.
No, I just want to ask a question. I'm not answering this question.
Ask.
It's about the eigenvalue of the principal component 2, where they got the 0.
Value of principal component 3.
Please, you said?
I was asking of the eigenvalue of principal component 3 and not 2.
Oh, okay, okay. Thank you. That's what I.
Your mind was like I was asking a 2, but I wasn't.
Yes.
I was asking.
All right, thank you.
All right. So now comes to my question. How many principal components that can explain the same information as original data did this approach select in this example? How many? The answer is simple, 6. You can see that it has selected 6. And you can count the 6 right here. And even though you see why I tend to mute you all. Even though I was interacting with Mary, I was expecting that by the time I come back, you would have gotten it. So if you have a question, you should raise your hand because I've muted all. So now let's go to the next question. Okay. The next question, it's a very, very important question. What linear combination of the original variable accounts for the largest variance? Correct to 2 decimal places. What linear combination of the original variable accounts for the largest variance? And this question is about the loadings. In fact, the largest variance can be found in which principal component? Who can tell us? The largest variance can be found in which principal component? Magdalene.
It's principal component 1.
Very good. Now stay with me there. Therefore, this question says that what linear combination of the original variables accounts for this principal component 1? What is it about? What is this about? Okay, you put your 1 mark down for your first answer.
No,
okay?
please. Am I supposed to answer this one too?
You don't know, don't worry.
I'm just asking. Okay, that's
Because that question goes to everybody. It doesn't go to you alone. It goes to everyone. So this question is simply about the equation of the first principal component. It is basically sort of like the regression line of the first principal component. So when you look at the first principal component here, okay, this column here, you are going to write the whole thing, taking note of the numbers. Taking note of the numbers. Because we are talking about linear combination. Linear combination is a line. It's an equation of a line. So you're going to use the loadings or the eigenvectors to create a principal component one. How do you do that? Well, look at it. Let's do it together. Okay. So if I were to write it, you don't miss words. The same words you use. You write comp. Let me just use red. You write comp dot, because that's exactly how it was written here. Comp dot one. So you write comp dot one equal to. Then you take the first one. What is the first one? The first number is 0.49, 2 decimal place. So you write 0.49. Then you attach the variable name. The variable name is var1. You put it down. The next one is minus. So you bring minus. Then you write the coefficient, which is 0.25. That one is here. So you write 0.25. Then you write the second name of the variable. That is var2. Then you do plus 0.50. Okay. And then you do var3. I'm sure you guys are following. And then finally, you go until you get to the last one, which is negative 0.34. Then you do var6. This gives you a lot of marks, by the way, if it was an example. So this is what is known as the equation of the first principal component. Write it down. Write it down. Write it down. Write it down. That's the only way it sticks in your memory. So this is the equation of the first principal component. And you can use that to find. Now, what about these ones like component 3? So when you are doing component 3, you don't need to bring 2 because component 3 is empty for 2. So when you write component 3 and you bring variable 2, you get everything wrong. It's the same way if you are writing component 6, okay, the equation for component 6, you don't need to bring variable 5. If you bring variable 5, all of it is wrong because there's nothing for variable. So this is how you exactly get your equation of the principal component. Okay, so you should be able to use this to get it. Finally, unless you have a question, how many principal components have the power to explain the information in the original variables? How many principal components? In other words, we have 6 principal components in all. How many should we select? Now, guys, if you check the notes, you will see that there is a heuristics to doing that. There's a kind of a strategy, an approach to doing that. And one approach is that select all those principal components whose standard deviation are bigger than 1, or whose eigenvalues are bigger than 1. Which principal components have got a standard deviation or eigenvalues bigger than 1? Component what? Components what?
1 and 2.
1 and 2. 1 and 2. So these are the, okay. Now, this is the first heuristic that you can use. Second heuristics, you can use the elbow effect. Elbow effect. Elbow effect. Elbow. Okay. So to get the elbow effect, we need to draw the scree plot. We need to draw the scree plot. What is the scree plot? Well, the scree plot is basically the percentage of the total variation in the data set explained by each of the principal components. So you normally will use this scree plot we're about to draw to identify how many principal components to select. Let's draw the scree plot. So go here and type plot. In the command, type plot, and bring your bracket, and type PCA. PCA was the name of the equation we had. So type PCA, do a comma. We can even type the type of line we want to draw. So do type. Okay. And then in the type, bring double apostrophe and type lines. So we want lines. And let's give it a color. Step out of the double apostrophe, write comma, then write COL for color. And then let's make the color any color. You can use any color. I will choose red. The moment you choose red, the color will change nicely to reflect. Then you do a comma, the line weight. Okay. The line weight, LWD. That can be 2, 3, 4, whatever number. The bigger you go, the thicker it becomes. So that gives us the line weight. And then you can now run it. And you should get the script plot beautifully shown. Now, of course, I've had an error. And it is normal when you make a typo. And I can see that the typo is because after the type, I didn't bring equal to. So I have to bring equal to after the type. Run it again. And there you go. You have your script plot. So you can see that the script plot will have an elbow. The first portion, the first time it bends, it curves. Okay. So looking at this script plot, where would you say that which component should we select? We will select up to the first time the script plot will bend. It will elbow itself. Where does the elbow show up? At what component? You can tell us.
4.
James.
Component 2.
Component 2. That's it. Okay. The bend, that whole thing starts at this point here. That is where it begins. And so we will select component 2. And there's no doubt that has been confirmed already by the standard deviation and the eigenvalues. So we are fully on the road. Okay, we are fully on the road. Now, this script plot, it can indicate the number of significant components. There are some other options that people have suggested in the literature, like July cutoff value and things like that. But the script plot here is key. It tells you that as the line goes down, gradually that component is losing its importance. Okay. Now, finally, the last one is the biplot. The biplot, now that you've gotten that you're dealing with 2, you now use the biplot to tell you how many components you select. But not just that, the biplot is an enhanced scatter plot. Okay, that plot the data along with the projections of the original features. It will do that and project them onto the 2 principal components that you may have selected. Let's do the biplot. This is the last one we are doing. Biplot. So type biplot. Type biplot, B-I-P-L-O-T, equal to, then bring a bracket. Type the name of your equation, which is PCA, and then you can include a color. So type COL equal to, and then type, because we are looking at colors, okay, we have to indicate 2 different colors, because we are dealing with 2 principal components. So let's take one color to be, so type color and bring brackets. Okay, and before the bracket, bring C. And then inside the bracket, we are going to type 2 colors. Okay, the first color is blue. So let's type blue. And then step out of that bracket. Step out of the clipboard, double apostrophe, and type the next color, which we will call red. So we're going to do a biplot of this and see what's going to happen here. I made a typo. So let's double check. Unexpected comma. Biplot. Where is my unexpected comma that says? Biplot. PCA. COL. Who has done this and there was no unexpected comment? Because I don't see anything. I don't see any unexpected comment. Okay, let's leave it like this. Let's see. Yes, Messi. No.
Yes, my find the unexpected comma is after the PCA, the comma there. That's what it has indicated as there.
So yours is unexpected comma as well.
Yeah, but it has highlighted the comma after the PCA.
Okay. Who has been able to crack it? Quickly tell us the justice.
Doc, is about the equal to the biplot equal to. So if you eliminate the equal to and you run it.
It's true. Can you imagine? I can't believe it. It's true. So that's it. Remove the equal to and let it flow. Yeah, sometimes it happens. But when it happens like this, you don't worry. You can just let DeepSeek help you with the problem. So this is a biplot. So you can see clearly that some of the variables are actually moving towards some things. Okay, some of the variables are moving together and others are also moving to another. For example, if you see variable 5 and variable 6, you see that they have grouped themselves and there's variable 2. Do you guys see that? So when you look here carefully, you see that these variables are kind of grouped together and these ones are also grouped together. So and we are looking for only 2 groups. So it means that it's possible that these ones are going to be grouped together. So you look for these ones, verify that with your correlation. So this is where you go back to the correlation and go and check whether these ones are all getting significant correlation among themselves, which means they are highly correlated. And check whether the other 3 are also getting significant correlation among themselves. Okay. And it will be so. This one is so clear, but it's not all the time the rest are so clear. Sometimes you have to now look at it with critical eye and then go back to the correlations to ensure that they are actually highly correlated. Once they do that, you combine this and then give them a name. And here, what was a variable 2? Who can tell us the actual name of variable 2? What was the actual name? Sorry? Taste. And then variable 5 and 6?
5, freshness. 6, friendly employees.
Excellent. So on the basis of this, we can conclude that variable 2, 5, and 6 represent what? Remember, we had a name. They represent what?
Quality of service.
Sorry?
Service quality.
Service quality. Service quality. You can give them the name, service quality. And then the other one will be food quality. That's it. And you are done. Job done. You are cool. Okay. Now, if you know the variables, you see this principal component that we wrote, let me show you. This equation, suppose you're going to use this one for further regression.
Can they give me can you be entertaining for something?
Suppose you're going to give this one for further regression. This is what you would have done. Oh, come on. We finished. I just want to show you something for practical life. So if you were doing normal regression, you will just substitute the variable names here, and you will get the actual value for component 1. You get the actual value for component 1. So now you would have used this one to create a variable called component 1, and you go and put it in your regression, and then use that variable further in your regression analysis. Ladies and gentlemen, that brings us to the end of the entire caboodle. Okay. Now, next time we meet, we are going to look at factor analysis. We're going to look at factor analysis. That's it. If there is no question, have a wonderful day. Bye-bye.
Thank you, Doc.
Thank you, Prof.
Thank